All right, good afternoon and welcome to Leviton's Residential Product Solution webinar series. My name is Talia Salvador and I will be your moderator for today's session, LED Compatibility, a closer look at the industry, compatibility, and solutions. We just want to take a moment to thank you for joining us today and let you know that you can feel free to ask questions in the chat box throughout the presentation. You can send a question to each individual panelist or to the entire group. In addition, we'd like to remind you that while some of us are working remotely, we're conducting webinars from home. So we ask if there's any connectivity issues along the way, you just bear with us. So with us today are two of Leviton's product managers, Kyle Cohen and Tom Babbage. Kyle Cohen is a former engineer for our lighting controls line and our resident expert in dimming technology. Tom Babbage is also a former engineer and our guru on all things sensors and timers. So we hope to provide you with a valuable and educational learning experience today. And again, please feel free to throw those questions in along the way. All right, Kyle, so I'm going to turn it over to you now and thank you all again for joining us. Kyle, I'm going to unmute you here. All right.
Thanks, Talia.
Awesome.
Okay, so thanks for introducing me. My name is Kyle Cohen, Product Manager for Residential Lighting Controls at Leviton, specifically residential dimmers. And today we're going to be talking about LED compatibility. Okay, so first we're going to start talking about the background in the market. We're going to talk about where we've been, where we're going, and we're going to move right into dimming LEDs, some of the common applications, where they're used, and maybe some of the issues that we deal with sometimes when working with LEDs. Again, talk about some market applications and move over towards compatibility testing when my colleague Tom Babbage is going to take over. Lastly, we're going to talk about troubleshooting and then what Leviton has to offer. Background and market. So incandescent lamps have come out over 100 years ago and really have not changed all that much since they were invented. We have had the introduction of the halogen bulb, which is a little bit different, but it's all based on the same premise. When incandescent bulbs were invented, they were really only used for on-off applications until the first phase cut dimmer became available. These were very simple devices. It's really just a lamp and a resistor, and that's what is used to provide the different lighting that you need in different rooms of the home. The first phase cut dimmers that were offered were really analog devices. There were no smarts in there. You couldn't connect to Wi-Fi 100 years ago, so we really didn't have those types of needs back then. Then has come along recently the LED bulb, which has been used to try and cut down on some of our power usage. So we all know LED bulbs are tremendously efficient and really have cut down on how much power you need to produce the same amount of light output. Many homes today have older incandescent dimmers, these analog types of products, and use new LED bulbs as replacements. And we're going to talk about some of the issues that you can get into in those applications. So the evolution of lighting. We started out with these incandescent bulbs that I mentioned, and we identified the need of coming up with a more energy efficient solution. So that's when you see the CFL, compact fluorescent lighting bulbs in the middle, and that was in the mid-70s. It definitely reached more towards the 80s and the 90s as well before the LED bulbs came into the picture. At first, LED bulbs were very expensive, as I'm sure many of you can remember. $10, $20 for a single bulb. And that really put a pause on people adopting them and people starting to use them and the market penetration. You can see that back in 2012, we really only had 2% penetration of LED products, and they'd been around for a while at that point. People still used incandescents that were widely available, Energy, of course, was a concern, but it wasn't as prevalent as it has become today. Moving towards 2016, you can start to see the shift towards halogen, which is a little bit more energy efficient, and CFL from that incandescent. And that's when you start to also see some of the movement towards LED. That's 15% penetration. Not much, but it looked like the industry was starting to move over. In 2022, which is really only a year and a half away, we're expected to have 73% penetration of LED bulbs. I would say that incandescent bulbs are really only going to be, there until they have to be replaced. If you look around, really anywhere, you're going to see new construction being all LED products, and really most replacement products being LED bulbs or fixtures as well. When you look at the top of the screen, you see how many different sockets there are throughout the house that need lighting, and you really think about how much energy can be saved by switching over to LEDs. And you also see the opportunities for dimming in different locations, such as the bedroom, the kitchen, the living room, the dining room, and so on. So now we're going to get into dimming, which is a little bit more complicated. When you look at the older incandescent bulbs and the incandescent loads, the dimmers were, like I mentioned, very simple. An incandescent lamp is really just a resistor that when you apply power to it, it illuminates and it lets out light and heat. Since the circuit for an incandescent bulb is so simple, you can use a very simple dimmer where you just provide phase cut power to the bulb, and it results in a stable light output and exactly what the customer is looking for, or the user. Types of incandescent bulbs can really dim very low because there's no circuitry in it. It's just almost a cause and effect with these types of products. Newer LED lamps are made to look like incandescent bulbs, but they actually perform very different, and they're actually built very differently. So if we look at an LED bulb, you can see down here the circuit is very different. It's much more complex. This is actually a simplified circuit. The actual ones that you would see if you cracked open a bulb are actually much more intricate. Now, because these circuits are so complex, you require a much more sophisticated technology in order to control it. The dimmer has to do much more in terms of regulation and and correcting the exact time where it turns on and off in order for this chip and this circuit to work properly. Additionally, not just controlling it, but the light output from an LED is very different as well. You can get problems such as flickering, fluttering, dimming range, slow turn on, and so on. And those problems are minimized by the way that we drive them from the dimmers. So I'm going to talk about a little later some of the lighting controls that are really designed to control LEDs. If you were to use a standard incandescent dimmer with some of these LED loads, it's possible that you might get okay performance, but it's more than likely that you're going to see one of those performance issues that I mentioned, like flicker. So when we compare them, looking at them next to each other, you have an older, simple resistive circuit versus a complex driver circuit. That complex driver circuit, of course, is used to control the LEDs rather than just turning on or off a resistor that's going to produce the light. Incandescent bulbs had very high performance with older incandescent dimmers or with newer LED dimmers. There really wasn't much to it, if you will. You could dim all the way down to 1% or even lower depending on the control that you're using. When we talk about LEDs, all of the efficiency that we're getting with LEDs causes some of those dimming issues. When we try and do things with very small amounts of power, things can potentially become more unstable. A good target for LED dimming is 20% or lower, although you'll see in many cases dimming can get down to even 10%. As LEDs get better and better every month or year or 5 years, you'll more than likely see the energy efficiency go up and the performance go up, which means you can dim lower and lower. I mentioned a couple times already, incandescent bulbs, you're really not going to see any flicker. There's really not all that much going on there as compared to some of these LED lamps. So taking a step back from the bulbs and bulbs or fixtures and talking more about the dimmers, we have a major comparison point between what you're using and when you're using it. And that really comes down to if you have a neutral. When we talk about neutral wires, we say we have 2-wire dimmers, we have 3-wire dimmers, but when you boil it down, that's really what we're saying. Now, 2-wire dimmers work where you have the power coming in from your source or your breaker panel and going through the dimmer and then out to the lighting load. Any power that the dimmer needs to use for control is then being, let's say, leaked through the lighting load. For 3-wire dimmers, when you have the neutral in the bottom diagram on the right, you'll see that we have a direct connection to the back side of the power source, if you will. We don't need to send any additional current through the load, which could cause instability. We have a direct connection. Because of that, we were able to do a couple different things. I'm going to talk about those in a second. To know if you have a 2-wire or a 3-wire solution depends on a couple different factors. One being when your home was built. If your home was built in 2011 or more recent than that, then code requires you to have a neutral wire in each switch box. If it were before 2011, then it really depends on the builder or the contractor, as well as where it's located in the house or what else is on that circuit. So it's really, you can't just say my house was built in 1972, I definitely have a neutral. It really depends on a bunch of other circumstances. One of the big challenges to this is that, one, people don't know, like I just mentioned, until you actually open up the box, and 2, more advanced controls really require that neutral wire.
Hey, Kyle. So just quickly on the neutral wire situation, I've always been, I guess I'm wondering out there, what % of applications have a neutral wire? So I'm going to be putting up a poll right after this slide, and I'm hoping that everybody on the line can just take a second and just vote for me. So you're going to see what % of applications have a neutral wire in the wall box. And if you guys can just let me know if that's 100% of them, maybe 75%, 50%. This is something that we're always wondering here at Leviton, what's out there in the field. So I'll just give you guys a few more seconds to vote. Thank you so much for replying so quickly. I see a lot of you are taking the time to vote here. Thank you. All right, so I'm going to share with you, and it looks like, Kyle, looks like about half of applications that our audience has come across have that neutral wire in the wall box. So,
well, that's
cool.
Great. It makes it much easier. It makes it much easier for our customers and to use the right types of products for the right applications. That's great.
Yep, absolutely. All right.
So and just Talia, as time goes on, we'll see that number increase. I mean, as you have homes getting a little older and as code requires all new homes to have the neutral wire, eventually we're going to start to see that number, continue to rise until one day everyone's going to have a neutral wire in all of their switch boxes.
Makes sense.
All right, continuing on to the types of products that can be used in each application. So 2-wire, as I mentioned, the most common and really the quote-unquote worst case situation, you can still control LED bulbs. I mentioned earlier, incandescent bulbs, the most simplest of dimmers are required. 2-wire is not a problem. Additionally, some newer designs that all of the major lighting control manufacturers have created are able to control LEDs with 2-wire dimmers. Now, although there have been iterations of dimmers over time. All of Leviton's newest products are really optimized for performance, and really we've gone out and tested as many bulbs as we can, and we continue to test bulbs to make sure that we provide the best performance that we can. Now, in 2-wire, it's not just LED, it's also the CFL bulbs, even though those are getting a little bit lower market penetration. Lastly, you'll see MLV as one of the rated loads that can be used with 2-wire products. Now, MLV and ELV stand for magnetic low voltage and electronic low voltage. I'm sure that many of you have seen the 1-inch or 2-inch eyeball lights in different applications that usually use transformers to provide power to a low voltage light. That transformer can either be a magnetic type or an electronic type. It might sound confusing, but it's actually very important. And we're going to get into those differences in a second because they have different requirements. Now, when we get into 3-wire, you can do everything that you could do in 2-wire and more. In 3-wire, we sometimes can see better performance with LEDs because of, like I mentioned, you have that direct path home, that direct path to neutral. So we can get a little bit better dimming range sometimes and a little bit better performance. Additionally, you have the ability to control ELV dimmers. And then lastly, what everyone's probably interested in is smart dimmers, where in 3-wire applications or in smart dimmer applications, you need a little bit more power in order to connect directly to Wi-Fi or connect to Z-Wave or Zigbee or HomeKit. And by having that neutral, you're able to really do all the communication that you need without causing any problems with the load. We can have a whole separate webinar on smart controls and load control also, so I'll save some of that. Looking into these specifically, I mentioned some of these before, but I'll just briefly touch on them. Incandescent controls, since they were so simple, they were very inexpensive. They did not cost that much to manufacture, and they weren't listed for LEDs. They weren't designed for LEDs. So using incandescent-only controls with LEDs is not only a safety issue, it's also a violation of the NEC code. Aside from that, you're more than likely going to have performance issues that are going to result in problems. LEDs are some of the main benefits for LED dimmers are that they were designed for this and they've been optimized for this over time. They can replace these 2-wire LED dimmers can replace your existing incandescent control, and although it has a small cost increase, it has a significant performance increase. ELV dimmers specifically may be able to provide an even higher level of performance with LEDs because of the different type of control. These definitely require a neutral connection, as I've mentioned, and these are definitely going to be your highest cost of all the types of load controls on the market. So when we talk about different types of load controls, you're going to hear forward, reverse phase, you're going to hear leading edge, trailing edge. Really what this means is how the physical bulb or fixture is being controlled. Now, when we talk about forward phase dimming, we're saying that the signal is being cut on the front edge, on the front half, the forward half of the wave. So if you look at this green line over here, that's a normal sine wave. That's, let's say, full power. Now, when we're trying to dim the signal down to 50%, we turn on halfway through. And that's really where the forward phase comes out of it. We're waiting to turn on, where it's actually the opposite for reverse phase. I'll get there in 1 second. Depending on how much you want to dim is how early you turn on. Now, forward phase controls are always used in 2-wire dimmers. Sometimes they're also used in 3-wire dimmers based on the application. For sure, they have the largest install base because of all the incandescent controls and because of all these 2-wire LED controls. Like I mentioned, in 2-wire situations, it takes a little bit of power in order for the dimmer to do this switching or to light up an LED or whatever it may be on the device. And that power is then transferred through the load to get back to home or to get back to neutral. Forward phase controls are incandescent, LED controls many of the time, CFL, magnetic, and then fluorescent. But we can save fluorescent for a different time because that can definitely get very complicated and require much different types of controls. One more comment on MLV is that magnetic transformers specifically require a forward phase signal. If you send a reverse phase signal to a magnetic low voltage transformer, you can get some issues. So you really have to keep in mind that if you're using low voltage lighting, you check what type the transformer is. Some other examples of this might be tape lighting, under cabinet lighting. Some outdoor lighting is low voltage. So it's just always important to check and make sure that you have the right load for the right dimmer for the right type of load. If you look at a reverse phase signal, trailing edge, reverse phase, it's all the same thing. You see the green signal again, that same sine wave, but now we don't cut the signal at the beginning of the wave. We turn on and we maintain on until it's time to turn off. And that's how we look at it. We're turning off on reverse phase rather than turning on at a specific time. In order to dim lower, you turn off earlier. In order to dim higher, you turn off later. And of course, if you didn't turn off at all, you would be at that maximum level. Reverse phase dimming requires MOSFET-based technology. So whereas forward phase was able to use much more inexpensive triac technology and components, reverse phase needs MOSFET-based technology. In order to do this, we do need a 3-wire system. So we do need that neutral wire. Definitely a much smaller installed base because of, it's only for electronic transformers and some, we'll say, pesky LEDs that we need to switch over, but which results in really a much higher cost of the product. Now, ELV loads, like I mentioned, MLV before require that forward phase. ELV requires reverse phase. If you use forward phase with an ELV load, you're going to get severe flickering. So again, always important to check. You never want to have to go back and change something out because of performance issues. It's really important to make sure that you have the right dimmer for the job. Now we're going to talk about compatibility testing. This is the time that Tom's going to take over, and Tom Babbage, here you go.
Okay, so first up, let's talk about a couple of realities in the home. We did some surveys, and what we found was that over half of homeowners use a dimmer. But what that means is just about half of homeowners don't have dimmers in their home. And that's a great opportunity for when you guys are out there doing service calls on a house to upgrade them and install some dimmers for them to improve their life, improve their the functionality and energy savings in the home. And one of the other things too is where years ago, when you went out and bought a light bulb, you had to specifically buy a dimmable bulb. But today, most LED bulbs are already dimmable. So most of the bulbs they'll have in the house and in fixtures will already be dimmable. They're just not controlling them with a dimmer. So the other thing we noticed is that 1 in 4 people that had a dimmer did in fact have compatibility issues. They had some dimming challenges with the LED bulbs.
Hey, Tom, so one of the things we wanted to ask our audience here, if we had a minute, was how often do you encounter LED dimming compatibility issues in the field? So I'm launching this poll now. You have a couple of selections here. Maybe you never come across issues and you'd say it's less than 10% of your sites. Maybe it's between 10 and 30, or maybe it's happening all the time. Is it more than 30%? Now, I don't know if I'd believe that you'd never get compatibility issues, but we definitely want to hear from you guys and find that out. So I see a lot of you are voting so far. Thank you so much. I'm going to leave that up for 10 more seconds. And it looks like, wow, looks like a good amount of you are having some issues. All right, so let me close this poll and I will share the results with you. All right, Tom, so there you have it. Between 10 and 30% of sites out in the field experience LED dimming compatibility issues.
Wow, so that's in line with what end users are seeing, which is very interesting.
Absolutely. Thank
Very
you to all who
interesting.
voted.
Yes, that's great information. Okay, so what some of the issues that they see when they do have when they do have some compatibility will be reduced dimming range, whether it's the high end, the bulb doesn't go as bright as it can be, or it doesn't go down low enough, so you can't dim the brightness of the LEDs low enough. You can also see, of course, everybody's seen the flashing or the flickering of the bulbs where they go on and off. Sometimes you could see it delayed on or delayed off as you're turning on the lights. It'll take some time to get to brightness. And then we've all heard, particularly with fluorescent bulbs, with the humming, but that can also happen with LED bulbs, whether it's the bulb or the light fixtures that are humming, or sometimes the dimmers. It's more likely the bulbs and the fixtures will be dimming, but you can have either side hum. There's also what we call choppy dimming, and choppy dimming means that when you raise or lower the brightness of the bulb from high to low or low to high, the brightness doesn't go linearly. It'll jump from 10% brightness to 30%. It sometimes happens at the low end. It sometimes happens at the high end. Uh, but one of the other things you can see is choppy dimming. And then there's just various inconsistent performance throughout. It depends on the combination of light and dimmer. There's other things that end users can see. So some of the realities in the marketplace, LED technology is constantly changing. Not only the LEDs getting more efficient, but the drivers that control them are getting more efficient. They're getting more cost effective, so prices are coming down, and there's constantly changes in the LED market. You couple that with the lighting fixtures are continually changing. There's more form factors. You see a lot more LED light strips. Rather than years ago, we just had an E26 or a standard Edison bulb. But there's many more lighting fixture types in the market, and the frequency of new lighting into the market is increasing. So we're seeing traditionally an LED bulb will be replaced within 9 to 12 months when it comes out. They'll cost reduce it, they'll make it more efficient, they'll make changes to it, and it'll be different 9 to 12 months from now. So LEDs are constantly changing, and testing is a never-ending process because of the constant influx of new uh, fixtures and luminaires. And the industry has taken a look and has come up with a few standards to try to measure flicker and even put limits on flicker. There are many measurements. There's Energy Star uses flicker percentage and flicker index. California has their own standard on flicker and how to measure and control flicker. There's standards from the IEC and a variety of different industry, but each one is subtly different. So depending on who you go to and who does the testing, you may actually get different results when you do compatibility testing.
Hey, Tom, really
Yes.
quickly, so if I could just ask, I'm going to deploy one more poll here on our webinar, and everybody's been so cooperative, so thank you so much. But we want to know, when you have LED compatibility issues, who do you look to for support? So you'll see that poll open up right now. And whether you're going to the bulb or the fixture manufacturer, maybe you're going to the dimmer manufacturer, the distributor, or maybe you don't do any of those things and you're just gonna say none of the above. But we're gonna leave that poll open for a few more seconds, but thank you to the people who have voted so far. I appreciate that. All right, so let's see. We are gonna close this poll and I will share with you. It looks like we have a good amount going to both the dimmer manufacturer and the distributor, Tom.
Oh, that's interesting. That's
Yeah.
interesting. And it's and you'll see when we cover testing why it's important to go to the manufacturer, for instance, or and we would recommend coming to us, and I'll explain why.
Very cool.
So so more in testing, NEMA has come up with a standard for testing, and all the manufacturers, whether it's a bulb manufacturer, dimmer manufacturer that participate in NEMA, test their lamps in accordance with a variety of standards. They test the lamps with a standard waveform. We test our dimmers with a standard synthetic load. And the theory is if they work with these standard loads and generators, they will work with each other. And what you'll see from the bulb manufacturers and the dimmer manufacturers is that logo in the lower right appear on the cartons. So once a manufacturer has tested for compatibility in accordance with the NEMA standards, you'll see that logo. And in a few short months, you'll be seeing that across the Leviton dimmer family. You'll be seeing that on our packaging. But one of the challenges there is you're really still not testing a dimmer with a specific bulb. You're testing it with uh, synthetic loads and synthetic generators. So that's why we recommend coming to Leviton website. And the reason is testing has its challenges. There's different methods, as we showed earlier, with the different industry standards. There are continual changes in the LED lighting side of it, the continual new products that come out, replacing old products. Plus, there's different performance based on the equipment they use, depending on the flicker meter, whether it's the power supplies. There's a lot of inconsistencies in the tests. What we've done at Leviton, we have everything in-house. We work with all our manufacturers for bulb manufacturers. We supply them with bulbs. They supply us with, we supply them with dimmers. They supply us with bulbs. We test for a variety of factors, including dimming range, irregular and irregular functionality of the dimmer. So the flickering, we'll measure flickering, but we'll also do observational tests. We'll listen to the bulbs to make sure they're not humming. We'll listen to the dimmers. We'll make sure they're smooth dimming up and down. Look for all the challenges that end users are seeing with the dimming and bulb combinations. And then we put together our ratings and we come up with our best combinations. We then publish all those results on our website, www.leviton.com/LED. And we regularly update the tool. We have tens of thousands of ratings up there. So if you go online, you'll see something like this. So if you go to leviton.com/LED, you can either select a bulb, and then you'll look for the dimmers that are compatible with that bulb. Or if you have a dimmer in mind and you wanted to know what bulbs are compatible, you can go to the dimmer, select the dimmer, and it'll give you all the bulbs. You can then filter the bulbs for your application. So let's say you wanted a 6-inch recessed lighting fixture in 2700 color temperature, 60 watt equivalent. You could filter the results specifically for your needs and for your application, and then you'll get a list of all the bulbs that are compatible in that category. So it's important that we work with the bulb manufacturers because, like I said, we really want to have one set of ratings. You don't want to go to a bulb manufacturer and find out one set of products are good, but the dimmer manufacturer recommends something different. We're trying to work with each of the manufacturers. Again, like I said earlier, we're sending them dimmers, so they have the latest and greatest dimmers to test with. They're sending us bulbs in return, and we're constantly testing with all the bulbs in the industry, all the bulbs in the marketplace, as they come out with new fixtures, as they come out with redesigned lighting bulbs and fixtures. We're constantly testing and updating our site. So for the best, most up-to-date information, we recommend coming to the Leviton site. And one of the things working with the bulb manufacturers, many of them, they don't go back and update their information. So for example, if they came out with a bulb 6 or 8 months ago, they won't continually test that bulb with, let's say, new dimmers in the market or current dimmers in the market. And so for the most accurate, latest and greatest information, we highly recommend the Leviton site. So with that, I'd like to turn it back over to Kyle to discuss troubleshooting.
All right, so now I'm going to talk about troubleshooting. So let's say you didn't go to the LED tool like what Tom was talking about, and now you're experiencing LED compatibility issues. Let's say the LED lamp doesn't dim or it flickers throughout the range, or you have one of the other problems that Tom was mentioning. The first question is if you actually have an LED dimmer. I mentioned earlier a couple times, if you have a much older incandescent only dimmer, it's likely that you're going to have issues. The second major question is the LED bulb or lamp or fixture actually dimmable? And the easy way to do this is to check the package. There are a lot of different LED products on the market that are intended for the lowest cost application that are not dimmable. Of course, as you can expect, if you try and dim them, you're going to have issues. The last solution is that making sure that they're compatible, and that's really the crux of what Tom was talking about going in, checking the leviton.com/LED tool and making sure that you have products that will work together. I guess the conclusion here is avoid problems by making sure you don't have them in the first place, but I guess it sounds easier than it is. If you have the problem called LED ghosting, where your LED lamp is still on when the dimmer is in the off position, that's what we call LED ghosting. The biggest solution for that is to take a look and see if your dimmer has a locator light. And what a locator light does is when the dimmer's in the off position, you may see a little glow, whether it's normally at the bottom of the device. And that's to say, that's to help find the device in the dark. Now, like I mentioned before, in 2-wire dimmers, in order to power that light, you have to leak certain current through the load. And some sensitive LED bulbs may turn on or flicker slightly when that's happening. The solution for that is to turn the locator light off. And all of our dimmers have that feature. You'll see in the picture on the right the little LOC indicator, and just switch that position to off, and that problem will be resolved. The second issue that you may see is flickering at the lowest dimming range, and that's usually at the minimum level. Now, what you can do here is go into the minimum adjustment settings of the dimmer and either raise or lower that level. If you have flicker at the lowest level, generally you'll have to raise it. If you're looking to get a better or a wider dimming range, you can lower it until you get to a point where the bulb may flicker. Now, the minimum adjustment is very straightforward. Leviton offers a programmable minimum adjustment where you just go in and you flip a switch over, set the level, and then flip the switch back to confirm. You should definitely take a look at the product instruction sheets or the product videos to see how it may be a little bit different based on what dimmer you have, but generally that's all you need to do. And in many cases, raising that level a little bit will get rid of your flicker and definitely get rid of a bunch of frustration. Our last troubleshooting tips are if you have poor dimming range or performance, or if you have inconsistent dimming. The first one, we always are going to recommend using dimmers that are rated for LED with dimmable LED lamps. Now, if you go into an application and you're not familiar with the dimmer, you can always take a look at the top right to see the load ratings on the product. If it's not there, you can check the back of the device, or you can always find it online on the Leviton website. You'll see now we provide the wattage rating, and for LED we also provide the amperage rating, because different LEDs are marked in different ways. Again, we're going to keep bringing home the point that, you know, using the Leviton LED compatibility tool is really going to get you a product where you can get the best performance, and you can be sure, you know, and kind of take the guessing out of it. The last thing has to do with inconsistent dimming, because you have multiple types of dimmers on the same branch. Now, if you have an LED and then you have a magnetic and you have something else and something else, that's when you can run into issues. It's really difficult to test the you know, millions of different types of combinations there. So we recommend using the same type of lamps on the same branch. Also, of course, which is not just Leviton's recommendation, but also the NEC and UL, that you can't exceed the dimmer's load ratings. If we say 600 watt incandescent, 300 watt LED CFL, that's what we tested to, that's what we proved that the device can handle, and that's what we expect that the applications will remain within. And we, of course, test all the way up to those to make sure that everything's working properly in as many applications as we can come up with. Lastly, we'll talk about what Leviton's doing, what products we have, and where we think you should go. So we have LED and incandescent CFL options in all of our different form factors. You'll see on the right, if you want something that looks a little bit different, you can really find it in the Leviton portfolio. And we have the LED, incandescent, magnetic, electronic, really throughout in many different form factors. I'll mention again, they have really significant improvements over incandescent controls to get the best dimming range, the best performance, and really some more flexibility with the minimum adjustment technology that we employ. Lastly, the LED compatibility tool. We have all of these products on there, so really you could just click through, find the product that you want, and the bulb to match it. Then lastly, of course, we have 0 to 10 volt controls for different types of applications that may be more commercial based or high end, and smart dimmers in the Decorus Smart portfolio. We didn't really mention 0 to 10 all that much today because it's a very different type of technology. Although we see it growing traction in some applications, it's a much more consistent type of control, since you have a built-in ballast or driver on that 0 to 10 volt fixture. I'm sure that Talia will set up another webinar and we can really dive into the 0 to 10 volt at some point in the future as well, if anyone has any questions. But that's all that we have for today, and we definitely are asking if you guys have any questions, just send them in this chat, either directly to me or to Talia or to everyone, and you know, we'll answer everything that we can. And thank you.
Thank you so much, Kyle. Thank you, Tom. That was a great presentation, and we actually have a bunch of questions here. So let me just take a look. The first one is, how does the new NEC code affect what dimmers we can use in new construction?
That's a great question. From what I understand, the question is, I think that's more referring to ground leakage. Now, in new construction, the new NEC says that if there's a neutral wire available, which it is in new construction, you cannot leak current to ground. Now, in the Leviton dimming portfolio, we only have 2 products that are ground leakage products, and that is our Decora Digital DD-L06 dimmer in Bluetooth and in non-Bluetooth options. Now, even though those can't be used in new construction, we did come out with a DDM06 dimmer, which is a neutral-based option for those types of applications. Now, we expect if you do not have a neutral available, you choose the option that does not require a neutral. If you do have a neutral available, you choose the option that does have a neutral, not only for the variety of reasons that we spoke about throughout the presentation, but also because it is a newly coming NEC requirement, which I believe, and Tom can correct me, is the 2020 NEC, which is partially adopted throughout the country. Tom, you want to mention
Yes.
what we have going on with sensors?
Yes. So actually, the NEC code is 2017. If your state is on
2017.
NEC 2017, but there was a little subnote for this specific requirement. It was implemented January 1st, 2020. So it's kind of confusing, but it's the 2017 code. If your state's on that, no leakage to ground, and the effective 2020 with any permits filed after January 1st, 2020. So we're probably starting to break ground on permits filed this year, in which case that code would apply. On the sensor side, our occupancy sensors, most of them are ground leakage, but we do have a family IPS15 and IPV15 that are neutral based, so those could be used for new construction.
Great,
Oh,
thank you, Tom.
thanks, Tom. So our second question here is, can I use an incandescent dimmer with LEDs if it dims well?
Another good question. Although you'd think the answer is yes, it's actually no. We've gone and looked through the NEC code, and the NEC requires that the dimmer that you use must be rated to control the load that you're controlling. And the reason is not just, a paperwork requirement, right? This isn't just the NEC saying this to say it. The reason is that incandescent controls were made, obviously a very long time ago. At that point, you don't know what the rating is. You don't know if it can even control LEDs internally without causing damage to the dimmer. It's a safety issue rather than a performance issue. I mentioned a couple times that performance is generally going to be poor. There will be applications where it works fine, but there's no reason to take the risk of the device potentially, resulting in an unsafe situation because you don't know what rating that product would have, and that product had never gone through an agency certification for that rating.
Okay, thank you, Kyle. Another question I have here, will compatibility of a bulb or dimmer pair vary with the quantity of bulbs in the circuit?
So I'll take that one. So yes, the application, how many bulbs you have in the circuit, how long the wire run is, and a variety of other things. What other devices are on that line can impact the performance. And that's why we've come up with our own internal standards. We've taken the industry standards, modified them, and we're a little more stringent with our requirements so that way in the field you don't have as many variants of what we test to and the ratings we present. So yes, in short, what you'll see in the field may vary depending on how many bulbs in the circuit and a variety of other factors.
Makes a lot of sense,
Yeah,
Tom.
definitely. Yeah, and Tom, I think we've seen over time that generally lower wattage and less number of bulbs on a circuit is probably more of a worst case situation than if you load the dimmer closer towards that rating.
Okay, Kyle and Tom, thank you so much for the presentation today. And thanks again, all of you, for taking the time to join us today.